All right, I'm going to show you a technique in graphing log functions. There's several different techniques that you can use. Again, I like this method because it seems to be the cleanest and it's the one that students really do well with. So let's take a look at a function. F of x equals log base 3 of x. And I want to know what this looks like. Well, we've already seen that this is the inverse of some other function, right? So let me go back to the idea that this function here was the inverse of 3 to the x, right? Now that I can look at the base and I can automatically know that. Okay, if this was log base 5 of x, it's the inverse of 5 to the x. So what I'm going to do is I'm going to kind of use the fact that I know that this is the inverse. I'm going to create a t-table based upon this function. Here's x, here's 3 to the x. And I'm going to just plug in some points for x. So I'll plug in my standard points, -2, -1, 0, 1, and 2. Now the reason I'm doing this is because it's very easy for us to just plug in an x, raise 3 to that power, and figure it out. We know that if we were to have tried to create a t-table out of this, we would have to be sitting there with our calculator the whole time trying to figure out what the points are. That could take some time. So I'm going to just do this. 3 to the -2. Since we've done this before, I'm going to go quick here. This is 1/9. The next one would be 1/3. The next one would be 1. The next one would be 3. The next one would be 9. So I have these points, right? The points are -2, 1/9, right? So on and so forth. I'm going to take those points and I'm going to flip the ordered pairs around. So to find the inverse, right? To find the inverse, I flip the ordered pairs. It's 1/9, -2. It's 1/3, -1. It's 1, 0. It's 3, 1. And it's 9, 2. Now if I just plot those points, I'm going to have the graph of the log function. So I've got, let me see, I'm going to go out 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 is the furthest I go out in my x coordinates. My y coordinates go between -2 and 2. So at 1/9 I'm at -2. So I go out 1/9, I go down -2. At 1/3 I'm at -1. So I go out 1/3, I'm here at -1. At 1 I'm at 0. At 3 I'm at 1. And at 9 I'm at 2. And you can see you've got that graph, and we know that we're going to have a vertical asymptote of the y-axis. Remember, because it's an inverse, right? Instead of having a horizontal asymptote for 3 to the x, right? 3 to the x looks something like this. The inverse was flipped over, so it's now the y-axis becomes our vertical asymptote. So this is the graph of this logarithmic function. So just let me do one more example, and you'll kind of catch on, hopefully, on how you would graph these log functions. They're not too bad. I'm going to take a function that might throw you off a little bit, the natural log of x. Okay, so you're looking at that and you're saying, okay, I want to graph this, but I don't know what function to put here so that I can flip the ordered pairs. Well, you need to remember that this means what? Log base what? Well, the natural log is log base e of x. So therefore, when you come to your table, you're going to have x, e to the x is what we're going to actually come up with here. So you can do like -2, -1, 0, 1, and 2. And then you're going to have to find e to the -2. And there you will not be able to get away from the fact that you need your calculator. So I'm going to do e to the -2. I get about 0.135. Then I'm going to do e to the -1. So e to the -1, I get about 0.37. E to the 0 I know is 1. E to the first power, okay, you do that on your calculator, you'll get about 2.718. And then you get e squared, which will be, let me see, e squared, 7.38, something like that. So now what we're going to do is we're going to take these points and we're going to flip them around. So to get the inverse, and remember the inverse is what? This function, right? That's what we want. So it's 0.135, -2. It's 0.37, -1. It's 1, 0. It's 2.7181, and it's 7.382. And now we go to a graph. I know that my x values are going to go out to about 7. 1, 2, 3, 4, 5, 6, 7. and my y values will go between -1 and 2. I mean, sorry, -2 and 2. So at 0.135, I'm at -2, so that's really just a little bit to the right down, then a little bit more to the right down 1. 1 zeros here. 2.7, so I go 1, 2, 2.7, I'm kind of eyeballing this. And then 7.38, I go out here, and you're just trying to get a general idea of what's happening. See, the good thing is all these log functions look pretty much the same, just like the exponential ones did. We still have a vertical asymptote here of our y-axis. So that's the graph of the natural log of x. So just to summarize, if someone gives you a graph, right, or someone gives you a log function, like let's say log base anything, what you want to do is you want to look at a to the x, you want to make a table, here's x, here's a to the x, find out your points, flip them over, and plot them, and you've got it. Now, what would happen now if someone changed it on you and did something like this? How about log base 2 x plus 1 minus 5? Okay, so now we're getting into the realm of shifting. Let me do one thing additionally. Put a negative in front of this. Okay, so you got all kinds of crazy things happening here. Well, again, the first thing you're going to do is look at the base. You're going to come up with this table for 2 to the x. Okay, come up with your points, flip them over, and then you'll draw the graph. So you'll have something like this. Okay? Now this right here is just taking those points, flipping them over. That's just log base 2 of x. Okay? But now what you would do is say, okay, I'm going to take that and I'm going to do some shifts. Remember, if you add a number inside with x, that's a left or right shift. You go opposite of what you think. So you're going to take this picture, move it to the right one. Then you will reflect it over the x-axis. So it'll reflect, and then the whole thing gets moved down 5. So that's how you can still use this little technique here to come up with your general picture and then just move it around wherever you need to.